Hello, students of class 11. Sets. What is set? A set is a collection of objects. We say that a set is a what is a set? A set is a collection of objects. Is a collection of objects. Collection of objects where objects are well defined. Objects are well defined. A set is a collection of objects where objects are well defined. The main point is well defined. Example, a set of vowels of English alphabet. So each student of your class will write A, E, I, O, U. That is, the answer of every student will be the same. This is well defined. Similarly, a set of natural numbers less than 5, then 1, 2, 3, 4. This is a set because the objects are well defined, and if this question is asked in your class, every student will write the same answer. The answer is 1, 2, 3, 4. Now, if we consider a set of beautiful houses of your colony, then or of your surroundings, of a set of beautiful houses of your surroundings or of your colony, then this beautiful house, there is no definition of beautiful house. So since there is no definition of beautiful house, so the answer will vary from person to person. Suppose as beautiful house, there is no definition of beautiful house, so the answer will vary from person to person. That is, the house which appears to be beautiful to a person A may not be beautiful to another person B. So person to person the objects will vary. So this is not a set. Although similarly, if I say that a set of good boys of your class, then good boys, there is no definition of good boy. The concept varies from person to person. Some may define good boy as a boy who remains silent in the class. For some, he may define good boy as the boy who remains clean, whose dress is clean, who whose notebooks are covered. For some person, the definition of good boy may be the boys who get rank in the class. So there is no fixed definition of good boy. So it varies from person to person. So this is not a set. So now this is all about set. Now representation of set, how we are going to represent a set. To represent a set, that is, we take any, to represent a set, first of all, we take the capital letter of English alphabet. You can take A, B, C, D, etc. That means to represent a set, we take the capital letter of English alphabet, and then we write the objects inside the curly bracket. That means set is represented by the capital letter of the English alphabet. You can select any capital letter and then curly bracket, and inside this you will write the object. So set are represented in two ways. That is their representation of set. That means set are represented in two ways. First is the roster method. This is the roster method, or it is called as tabular method. And set builder method. So now let us take an example, that a set of vowels of English alphabet. So here we take a capital letter and then equal to curly bracket. The objects are A, comma, E, comma, I, comma, A, E, I, O, comma, U. So this is the roster method. Now here, in the definition it was object. So when we represent the set in roster method, then these are the elements. Then this becomes the elements of set A. Then this we say that this becomes the elements. They are the elements of set A. This is roster method. And in set builder method we represent like this. Small letter x, these elements are x. The elements of this set are x. We represent it with small letter, and then such that we have to define what is x. So x is a vowel of English alphabet. So this is a set builder method. So now again there is a term that is belongs to. Suppose if I say A is an element of set A. So this I have written in this in words. So mathematically, A epsilon A. This is a Greek letter epsilon. And it means belongs to. And this means belongs to. So A is an element of set A, which I have written in word. This can be expressed mathematically as A belongs to A. This is an epsilon. This is a Greek letter, and which means belongs to. Now again you see one thing, that is a set of a set of natural numbers, a set of natural numbers, set of natural numbers less than 5. So in roster method, it is represented like this. This is roster method, and in set builder method you will represent it like this. X, small letter x. What is this x? X is a natural number. X is a natural number less than 5. This is a set builder method. Set builder method. Now you can represent this statement in this way also. X has that. What is x? X, it belongs to natural number. Capital N represents natural number, and x is less than 5. That means the elements of this set is x, and what is this x? This x, it belongs to natural number. Since I have said it is natural number, and x is less than 5. So all those natural number less than 5 is 1, 2, 3, 4. So you can write in this form also. So this is all about representation of set. Now different kinds of set there are, that is empty set, empty set, empty set. That means there is no element in this set. Suppose A, there is no element. If we say that a set of natural numbers, a set of natural numbers, a set of natural numbers less than 1. So there is no natural number less than 1. So A, there is no element in this set. So such type of set is called as empty set, and it is represented by the Greek letter phi. It is represented by the Greek letter phi. This means it is an empty set. This is an empty set. So empty set is also known as void set or null set. This is also known as void set or null set. Null set. Now second is the finite set. So finite set, see finite set. Here in finite set you know the starting and the end. That is 1, 2, 3, 4, 5. This is a finite set. A natural number less than 6. Infinite set such as set of natural numbers. Set of natural number. Set of natural number. This is an infinite set because see 1, 2, 3, 4, 5, 5 and then dot dot dot, because you do not know the end point. So this is infinite set. And then equal set, if both the sets have the same elements, same number of elements, if both the sets have same elements, then they are equal sets. Now if they are same elements, then they are equal sets, because it is given here that for equal set it is clearly given that is two sets A and B are said to be equal if they have exactly the same elements. If they have exactly the same elements, they must have the same elements, exactly the same elements, the same elements. So now this is all about equal sets. Now I am going to subset. That is, if the elements of set A, if the elements of set A is the elements is the element of set B, then we say that we say that A is the subset of B. If the elements of set A is the elements of set B, then we say that A is the subset of B. In the book the definition is given that, and this is represented as A subset B. This is the representation of subset. In the book the definition is given: A is a subset of B. If A is an element of A, implies that A is also an element of B. Or a set is said to be a subset of set A if every element of set A is also an element of set B. This is the definition given in your book. That is same. I have told the same thing. If the elements of set A is the elements of set B, means every elements of set A, or in the book is definition. In the book the definition is given that every elements of set A, every elements of set A is the elements of every elements of set A, every elements of set A is the element of set B, or every elements of set A, every elements of set A is the element or is also the, I am giving this the book definition, is also every element of set A is also an element of set B. If also every element of set A is also an element of set B, then A is the subset of B. This is the book definition. I have given. It's the same meaning. If the elements of set A is the element of set B, then we say that A is the subset of B. That means every element of set A is also an element of set B. Then A is the subset of B. This is the representation of this is the representation of subset. This is a representation of subset. So now we are going to intervals. Subset. Now we are going to intervals. That is intervals. There are three types of intervals. First is the open interval. Then second is the closed interval. And third, it is the semi-open interval. Semi-open interval. This may be left open, or say right open. So the open interval is represented like this, and the closed interval it is represented like this, big bracket. And left open means this side is open and right side is closed. Right open means the left side is closed and right side is open. So this is about intervals. Now I am going to explain it. Suppose if I have written like this 2, 7, that means the elements of these sets are x greater than 2 and less than 7, means 2 and 7 is not included in this set. So if we represent in the number line, that is number line, if we represent in the number line, means in the number line we represents the real number, in number line we represents real number. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So it does not touch 2. At the same time, it does not touch 7. And you join the circumference from this circumference to this circumference. This is represented in number line. Means number line, this is a real, it represents real number, and this is about open interval. Now if you go for closed interval, if you go for closed interval, so the closed interval, it is represented as closed interval. Closed interval. So in this closed interval, suppose it is 2, 7. That means the elements of this sets are x greater than equal to 2, less than equal to 7. Means 2 and 7 is included in this set. So if we express it in number line, which represents real number, number line means it represents real number 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Means this number line, it represents real number. So 2 and 7 is included. We make deep and 7 here deep and join this. So this is how closed interval is represented. And now that is semi-open. For semi-open intervals, that means if we take left open 2, 7, that means x greater than 2, that means 2 is not included but less than equal to 7. 7 is included. So in the number line, it will be 0, 1, 2, 3, 4, 5, 6, 7, 8. In the number line, 2 and 7 will be deep. So this is how we represent left open. And if it is right open, that means 2, 7. So this means x greater than equal to 2. This is your right side. So this is your left open, and this is your this is your left open because this side is open, left side is open, and this is your right open because this side is your right side is open. Less than 7. So in this number line, 0, 1, 2, 3, 4, 5, 6, 7 and 8. So here 2 is included but 7 is not included, and this is how we represent on number line. This is all about your intervals. Now power set. For power set, let us go to power set. So for power set, here power set, let us take a set A, 1, 2, 3. Now we have to find out all the subsets which can be made from this set, all the subsets. So see this set, this element is present in this set, so this is the subset of this. Similarly here again you see this is a subset of this. See, this is the subset of this. 1, 2. This is the subset of this. 1, 3. This is the subset of this. 2, 3. This is the subset of this. 1, 2, 3. This is the subset of this. And phi, remember that phi is the subset of any set. Always remember that phi is the subset of any set. Phi is the subset of any set. So if all these subsets are included inside, if all these subsets are kept inside, if we keep all these subsets, if we keep it inside a curly bracket, if we keep all these subsets inside a curly bracket, then this is called power set of A. It is represented by PA, and this is called as this is called as power set of A, and this is called as power set of A. This is called as power set of A. So now a number of elements in power set A. This n represents number of elements. Number of elements in power set A. This is equal to 2 to the power of modulus A. Modulus A, this represents number of elements. This represents number of elements in set A. So now number of elements in set A, there are 3 elements, 2 to the power of 3, so this will be equal to 8. Now we have to see whether there are 8 elements in power set A. So 1, 2, 3, 4, 5, 6, 7, 8. So it is correct. So this is all about power set. Now universal set, this is a universal set, this is the biggest set. You can say this is the biggest set, such as for example set of natural numbers, set of integers, a set of real numbers, and this is represented as like this capital letter U. Set of natural numbers, set of integers, set of whole numbers. And for solving any question, you can also create your own universal set. You can, for solving any question, or you can create your own universal set. So now this is all about set. Now there is a topic, that is Venn diagram. So Venn diagrams. Here what is that is the universal set. We represent the universal set by a rectangle and other set by a circle. We represent the universal set by rectangle and the other set by circles. So we usually represent the universal set by rectangle and then other sets by circles. Now we come to operation of set. Operations on sets. So let us see operations on set. Operations on set. First is union. A union, it is represented as small, as this, not small, by U. Capital letter, this is U. A is represented A union B. It defines that the A union B, first is union, and its definition is X such that X belongs to A or X belongs to B. This is the definition of union. So let A be the set 1, 2, 3, 4 and B be the set 3, 4, 5, 6. So A union B, this will be 1, 2, 3, 4, 5, 6. In set, you remember that repetition is not allowed. Since 3, 4, it will come only one time in this set. So in union, you see that all the elements of set A and all the elements of set B are included in A union B. This is A union B. So again, I am going to give another example of union. So see, that is A is equal to 1, 2, 3 and B is equal to 4, 5, 6. So your A union B will be 1, 2, 3, 4, 5, 6. This is A union B. So this union I can represent in Venn diagram. So if I'm going to represent union in Venn diagram, union in Venn diagram. So if A is a set 1, 2, 3, 4 and B is another set 3, 4, 3, 4, 5, 6. So here you see two elements are common in set A and set B, so there will be an intersection this A. So here you see 1, 2, 3, 4, 3, 4, 5, 6. So A union B will be, this is the Venn diagram, and you said it, this is the A union B. You said it, this area, this shaded portion, this is A union B, and this is the universal set, the rectangle. Now let me take another example, that is A is equal to 1, 2, 3 and B is equal to 4, 5, 6. 4, 5, 6. So here again you see rectangle, two sets A and another set B, 1, 2, 3, 4, 5, 6. Here you see A union B, all these elements will be included. So you said it like this, because A union B, this will be 1, 2, 3, 4, 5, 6. So you said this, the shaded portion will be A union B. This is the representation of A union B in Venn diagram. So again there are some properties in A union B. There come some properties in A union B, that is these are some of the properties. These are some of the properties of A union B. That is, A union B is equal to B union A. This is the commutative law, which we call as commutative law. And again A union B union C is equal to A union B union C. This is the associative law. And again A union phi is equal to A, means union with null set, any set, union of any set with a null set, is the set itself. So this is called as law of identity element. Means phi is the identity of union. Now again A union A is A and U union A is universal set. This is called as the idempotent law. So these two are important, because if you union with any set, when there is union with phi null set, we get the set itself, and when there is union with universal set, we get the universal set. Means in union, actually union, when there is a union between two sets, a technique to remember that when there is a union between two sets, then the answer will be always the bigger set one. When there is union between two sets, your answer will be the bigger set. So here A union phi, A is the bigger set, so in union your answer is A. U union A, your universal set, this is the bigger this is a bigger set, so your answer will be the bigger set. In union we get the bigger set. So now we go to intersection of sets. So intersection of sets, intersection of sets. So here this is represented as like this. The symbol is inverse of u, and its definition is, your definition will be simple: x such that x belongs to A and x belongs to B. The only, this is very important. In union, your definition, in union here it is or, and in intersection here it is and. In union you find that in the definition here it is or, and in the intersection it is and. So let me clear it by the help of an example. Let A set be 1 2 3 1 2 3 4, and your B set be 3 4 5 6. So here A intersection B, this will be 3 4. This is A intersection B, this will be 3 4. That means the common. So here Venn diagram will be, your Venn diagram will be, this is A set and this is the B set, 1 2 3 4 5 6. So A intersection B, this is the shaded portion. This is the reason. So the shaded portion, that is A intersection B, this is the intersection, shaded portion, and this is the universal set. Now let me take another example. That is, take another example. A is equal to 1 2 3, and your B set is equal to 4 5 6. Then A intersection B, there is no element common, so it is empty set phi. Then these A and B sets are called disjoint sets. Then A and B are called disjoint sets. They are called disjoint sets. So there are some properties in intersection also, because it holds commutative law as well as associative law. There are some properties in this intersection. There are properties in intersection. Properties of the operation of intersection. That is, A intersection B is equal to B intersection A. This is commutative law. And A intersection B intersection C, that is A intersection B intersection C. This is associative law. Now the important law is with phi, that is phi intersection A. In intersection we always, the answer is always the smaller set. See, in intersection always the answer is smaller set. So U intersection A, this is A. But in union we get the bigger set. A union phi A, U union A, A. In union we get the bigger set, and in intersection we get the smaller set. And another A intersection A is the A. So this is all about the properties of intersection. Now we go to the difference of sets. Difference of sets. Its definition is like this. When it is represented as A, something like this, minus A minus B, something like this, and it is read as A, it is read as A minus, it is read as A minus B, it is read as A minus B. We read it as A minus B. So the definition is x such that x belongs to A, x and x does not belongs to B. X says that x belongs to A and x does not belongs to B. So let me clear it by the help of an example. A said 1, 2, 3, 4 and your B said 3, 4, 5, 6. Let me clear the example. X belongs to A and x does not belongs to B. So A minus B, this will be, you remove the elements of B from this set A. First of all, you remove the elements of set B. First of all, you remove the elements of set B from set A. You remove it. So only 3, we can remove only 3 and 4 because only 3 and 4 is means first of all what A minus B, that is you remove all the elements of set B. You remove all the elements of set B from A. You remove all the elements of set B from A. When you are going to remove all the elements of set B from A, you get only 1 and 2. So this is a difference, means x, this means this x, these are the elements x, it belongs to set A, but these elements does not belongs to set B. This is the definition. Means what you have to do, keep in mind that you have to remove all the elements of set B from A. So when you remove all the elements from set when you remove all the elements of set B, when you remove all the elements of set B from set A, your answer is this. Because you can only remove 3 and 4, because 3 and 4 are the elements which is present in B. So we have to remove the elements of set B. So we can remove only 3 and 4 and the rest left is 1, 2. This is A minus B. So this is about the difference of set. So from here, from the definition, you see the elements of this set belongs to set A, but the elements of this set does not belongs to set B. So in Venn diagram, we can represent this like this in Venn diagram, that is A is equal to 1, 2, 3, 4 and your B is 3, 4, 5, 6. So in Venn diagram, if I am going to draw in Venn diagram, say you get like this. If you draw in Venn diagram, if you are going to draw in Venn diagram, here you see A and B, 1, 2, 3, 4, 5, 6. So if you remove A minus B, this is the reason A minus B. This reason is A minus B. This is the A minus B reason. That is, this shaded reason is the A minus B. So similarly, this is, and if we this is A minus B. This is about the difference set. So I think so it is clear with you all. Now I am going to another topic, that is complement of set A. Complement of set. Complement of a set. So let me first of all write the definition. This is it is represented as A dash complement, that is equal to x such that x belongs to U and x does not belongs to A. So this is the definition. So let me clear it for you. To find the complement of set A, two things must be given to you. To find the complement of set, two things must be given to you. First, the set A. The set A, it must be given to you. This must be given to you. And an universal set, this must also be given to you. A universal set, this must be also given to you. As I have told you earlier that you can create your own universal set. You can create your own universal set. So this is the universal set. These two things must be given to you. Then only you can find the complement of A. The complement of A, that is, your definition is X belongs to U, but X does not belongs to A. That means you remove all the elements of set A. You remove all the elements of set A from universal set. You remove all the elements of set A from the universal set. When you remove all the elements of set A from the universal set, you get 4, 5, 6, 7, 8, 9, 10. This is A complement. This is A complement. And if you are going to represent in Venn diagram, so see, this is the box and this is the set A. This is universal set. So your universal set, this is the biggest set, so this set is included in your here. So 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10. So A dash is, so the A dash area, so your A dash area is the outside the A circumference, outside the A circumference. This is your A dash area. This shaded portion, this is your A dash area. This is your A dash area. This shaded portion is your A dash area. This is A complement. So there are also some properties of complement. That is some properties of complement sets. First is that the A union A dash, this is the universal, and this is also known as complement law. It is known as complement laws, and the complement laws this, and the second is that A intersection A dash is phi. So these are the complements law. Here you see, you can see that this is the A set and this is the A dash set. This is the A dash set. Here this is the A dash set. You can see this clearly. This is the A dash set. This is the A dash set. This is A dash. So A and A dash, they both together forms the universal set. So here A union A dash, it forms the universal set. And see, there is no intersection, so there is no common, so it is phi. Now another very important theorem is the De Morgan's law. This is very important. That is the De Morgan's law. De Morgan's law. This is very important. That is, first is that A union B dash is equal to A dash intersection B dash, and second, that is A intersection B dash, that is equal to A dash union B dash. So there are two D, one is for union, another is for intersection. So this is all about the operation of set. Now we are going to the last topic, that is the practical problems on union and intersection. That is the practical problems on union and intersection. So let me intersection of two sets. So see one thing here, this is the universal set, this is set A, this is set B. So here this region is A minus B region, and this region is the A intersection B region, and here this reason, this is the B minus A reason. Now this whole, you see this whole is A union B. This whole is A union B. So here you see A union B, this is equal to A minus B union. Union means you can say plus A intersection B and union B minus A. B minus A. This is A union B. So if you write like this, number of elements in set A union B, this will be number of elements in set A minus B plus number of elements in set A intersection B plus number of elements in set B minus A. Now let this be equation 1. Now you see this number of elements in set A, this number of this circle, it includes this and this both. So number of this A in set A, this includes these two reasons, both reasons. That is, the reasons are A minus B and A intersection B. Similarly, you see this B reason and B, it includes and B minus A and A intersection B. So this is equation 1 and this is equation 2. Now you see, you take the equation, first equation, A union B and A minus B plus N A intersection B plus N B minus A. So here you see A minus B. The value of A minus B, you can find it from here, equation 2. A minus B, that means Na minus your Na minus N A intersection B. This and A intersection B. And B minus A, you can calculate it from this equation 2, that is NB minus N A intersection B, that is NB minus N A intersection B. So here you see that this and this cancels out and it remains NA plus NB minus NA intersection B. This is NA union B. So we get 4 types of result. One is equation 1, this is a result. Equation 2, this is equation 1. This is equation 2, and another result. And see, this is equation 3, another result. And this is equation 4, another result. So we get this 4 results. And with the help of this 4 results, we calculate the practical problems. So this is all about set, which is in class 11. I have given you the theory, all this is all about sets. I have given it in the theory. This is all about the theory of sets. So thank you.